Hello everyone. So today I will be talking about functions. So I'll basically be taking through what they are exactly and how they work essentially. So functions. Okay. Let us consider let us consider two sets. So let this be A and A has elements 1, 2, 3 and 4. Now let us consider another set which is B, and this has suppose elements 3, 4, 5 and 6. So 1, if we can draw a line from 1 to 3, a line from 2 to 4, 3 to 5, 4 to 6. So what's the relationship between element 1 in A and element 3 in B? Element 1 is basically mapped into element 3. So this is basically what we call a mapping, where an element in A is mapped into an element in B. So as we can see, one element from A is mapped to exactly one element in B. So we can call this a one-to-one function, since it's basically one element of A to one element of B. Now let us consider another case. So suppose we have 1, minus 1, 1, 0, 1, sorry, my mistake, minus 1, minus 2, minus 1, 0, 1, and 2. Let this be A, and here let us have 0, 1, and 4. So suppose minus 1 and 1 are mapped both into 1, minus 2 and 2 are mapped into 4, and 0 is mapped into 0. This is B. So as we can see, multiple elements of set A are mapped into exactly one element in B. So basically, an element in A is only mapped at most to one element of B, but then multiple elements from A is mapped into one element of B. So we can see like minus 2 and 2 both map into 4. So minus 2 maps into 4, but it doesn't map into any other element in B. So basically, this we can call it a many-to-one function. Okay, sorry, a bit of slow in writing. Yeah. So essentially, as the name suggests, multiple elements in A are mapped into only one element in B. So now you have a rough idea of what functions are. So if we look in the first one, which is a one-to-one function, how would we relate the elements in A to elements in B? So suppose A was X and B was Y, we can represent this as Y is equal to X plus 2. Y equals X plus 2 is a one-to-one function. So suppose if X is A, so you can substitute elements of A into X and it will give you an output Y, which is elements of B. So suppose you substitute 1 into Y equals X plus 2, you get Y equals 1 plus 2, which is 3. And that is how 1 maps into 3 in B. Similarly, if you say you put X equals 2, you would then get Y equals 2 plus 2 is equal to 4. And 2 maps into 4. So therefore, this is an example of a one-to-one function. Now if we look on the many to one function, we can see -2 and 2 map into 4. 4 is the square of -2 and 2. -1 and 1 map into 1. 1 is the square of -1 and 1. And 0 maps into 0. And 0 is the square of 0, basically. So this function is basically y is equal to x squared, which is a many to one function. So now let us define a function. A function is basically any mapping where each element in A only has one image. Image is basically the output. One image in B. So you can't have a scenario where, suppose I have, suppose I have 0, 2, 4, 6, and 5, 7, 9, 11, and you have a scenario like this where 0 is mapped into both 5 and 9. This is not possible because how can one element be mapped into multiple other elements? So essentially, that's the definition of function. It is a function is a mapping where one element of set A has only one image in set B. So now you guys have rough idea of what a function is. So now we can see which how to identify one-to-one functions and many-to-one functions. So okay, I'm gonna draw a few graphs here. So let me just yeah. So here's one graph. Here is another one. Here is okay, sorry, another one. This is not facing to right. Yeah, and finally, okay. So let us consider the first one. As we can see, it's a straight line, and if we take any x value, it is only mapped into one value of y. And if we take any y value, it only has one input of x. So therefore, this is a one-to-one function. So let me write one-to-one function. Now let's look at the second one. So we can see that for each input x, there's only one output y. So it is a function. Now let's see if it is one-to-one or many-to-one. So if we just take any point y, so let's take this point y. So if this is 4, so 4 has two values of x which are mapped into it. So this can be x1 and x2. So this means since there are multiple inputs mapping into one output, this becomes many-to-one. We can then use the same logic for this third one, as we can suppose take this point, let this be -3. So -3 has three values of x being mapped into it. So it is a many-to-one function because many inputs are mapped into one output. Finally, let's look at the last one. So with the last one, we can see that for one value x, there is multiple values of y, but that can't be possible because by our definition of a function, an input value can only be mapped to at most one output value. So here we are seeing that one input is being mapped into two outputs. So this is not possible. So this is not a function. So whenever you see a graph, just you just select a specific point, suppose y, and like draw a line, a horizontal line, and see how many points it crosses. So that if it crosses multiple points, then that will mean it's a many-to-one function. If it doesn't if it only crosses one point, that means it's a one-to-one function. And then to decide if it is a function or not, then you draw like a vertical line, like at some point. As long as that vertical line does not cross 2 points, that is a function. Okay. So now let me introduce what the domain is. So the domain is essentially, if I had, suppose x, and this is to y, 1 2 3 4 5 6 7 8, that is y. The domain is essentially what you input. So this is the domain. It's basically what you input. And then you have the range. The range is basically the output. So if you have a domain which includes 1, 2, 3, and 4, like these are all the values in the domain, then the range of outputs will be between 5, 6, 7, and 8. So that's how the domain and range work. So now, if I consider, suppose y is equal to x plus 2. So if we draw that, we can say, yeah, it'll be something like that, right? So bearing there are no conditions, what would be the domain? Since there are no conditions, x can be all real numbers. So don't be confused by this notation. This means x is the member of a set of all real numbers. So all real numbers means that as x goes to infinity and negative infinity, any of these values, any of these integers or fractions or irrational numbers can be part of is part of the domain. So therefore, this is what the domain is. X is a member of all real numbers. Then what would be the range? Similarly, we can see that the line goes to positive infinity and negative infinity. So the range would also be y is all real numbers. Now, let us try this with like a domain where suppose x is between 5, you used to have y equals x plus 2. So so suppose this is 2, so the line would start from there, and this is 5 to go there. So this is basically what your line would look like. So since there's a domain, the line you have drawn is limited over a certain space. So therefore, you would also have a limited range, which is this would be your range. So to find the range, you basically substitute the domain. So the lower bound of the range would be, you substitute the lower bound of the domain, you would get y equals 2 plus 2 is equal to 4. Then the upper bound would be y equals to 5 plus 2 is equal to 7. And hence the range you can represent like this. Please note, y can be replaced with f of x. So like it doesn't matter. Like f of x, y, it's the same thing. Now let us consider the case of a many to one function. So suppose, okay, I have this. This is like y is equal to x squared plus 1. So the domain it goes to positive infinity as long as we don't put any conditions, and it goes from negative infinity to positive infinity. So x is member of all real numbers. Sorry, my pen's just a bit unresponsive. Yep. Give me a second. Yeah, find it there. But then could we say that about the range? So if we see here, the range goes all the way to positive infinity, but then it doesn't go below a certain point, and that is at y goes to 1. So therefore, we can say the range is y is greater than or equal to 1. So how would we find the range in these kind of cases? You can draw a sketch like this and see at which point does the graph doesn't go beyond. So in this case, we can see beyond y equals 1, we don't see the curve going beyond that. But another thing you can do is, if you have a square number, all square numbers are positive. So if you have a square number, suppose a squared would always be greater than or equal to 0. So here you have y equals x squared plus 1. So the minimum value of y equals x squared plus 1 would be when x squared is equal to 0, because x squared can't go below 0. So if you substitute 0, you get 0 plus 1. So this will be essentially your minimum value. Like the minimum value of y cannot be less than this. So therefore you can obtain your range. Now let me do like another example. So suppose you have a quadratic, like y is equal to x squared plus 6x plus 7. How do you do this? So the first thing you do before you sketch is you complete the square. Oh yeah, the domain is x is a member of all real numbers. They haven't put any conditions on it. So yeah, as I said, you complete the square. So you'd have x plus 3. Sorry, x plus 3 whole square minus 2. Now we have the vertex, so we can sketch this. So minus 3 somewhere there and minus 2 somewhere there. So we would have something like that. Now we can see that this is minus 2. The curve doesn't go beyond minus 2. So its minimum value is minus 2. So therefore, the range is y is greater than or equal to minus 2. Now suppose we don't sketch. How would we find the range? So where y equals x plus 3 whole squared minus 2. As I said before, any square number, it is greater than or equal to 0. So which one is the square number here? That is x plus 3 whole squared minus 2. Sorry, x plus 3 whole squared. That is the square number here. So the minimum possible value for this is 0. So if you substitute 0, you get 0 minus 2, which is equal to minus 2. So the minimum possible value for y is minus 2. the curve cannot go beyond that point. So therefore, that's how you would obtain the range in that case. So for today's video, that's it. So I have essentially gone over how you can find the domain and how you can find the range. So in our next video, I will talk about inverses and how to find inverses for many to-one functions and stuff like that. Right? So thank you guys for listening. I will see you in the next video.